Hi guys, today we're going to start looking at the quick quiz 4 in our notebooks. So if you can just move over to that and take some notes in your book on this one. What the question says is, for the following functions, state if they are odd, even or neither, and find their domain and range. That follows on directly from our lesson that we did last time on odd or even functions. I'm going to draw the graph first. I think that would be a good idea for you guys in most questions. If you can draw that, it gives you a little bit of a better understanding, particularly for domain and range. Not so much for odd or even, because we can do that just by substituting into the function. But let's have a look at it. The formula says x squared plus 5 is our first function for number 1. Well, the function f(x) equals x squared would look like this over here to the right. That's x squared, but we've actually moved up 5. Now we'll do a little bit more on transformations later on in the term, the next few weeks. But if you think back to what you did in year 10, when we had a number at the back, a plus 5 or a minus 5, that moved the graph up or down the y-axis. So we're going to move up to 5, and where our graph is going to cut now is at y is equal to 5. So it was the same shape as y equals x squared. We've just moved up to 0.5 up there. So that's what it looks like over here on the right. Just by looking at it, it's symmetrical around the y-axis. So I know that it's going to be even, but I could test that as well. So if we have a look at our notes that we looked at last lesson, an even function is a function where f of x is equal to f of minus x. And those functions are even if they are symmetrical or reflective about the y-axis. So if you have a look at our diagram over here, if I was to fold that y equals x squared plus 5 in half and use the y-axis as a fold line, both sides would be even. So it's definitely an even function from that. But we could also test that f of x is equal to f of minus x, and that would work on this one. Our domain for this graph, our domain are x values, okay, and our range are y values. So let's have a look and see what x values could occur. Well, looking at that graph, we could have all x values are possible in that range. Sorry, not in that range. I shouldn't use range. All x values are possible for that graph. So what I would say would be our x would be all, and I'm going to use the word real x values. We talked about the other day a little bit about the word real. And if you're just saying all x values, that's okay for now as well. Now, y values, or our range. Now, the only y values that we can deal with this graph is from this value 5 and above. So we need to have y greater than or equal to 5 for our range. And that's our range. Okay, let's have a look at our next one. Number 2, f of x is equal to 1 over x. Now, this is a graph that you guys need to know, need to be familiar with, and you have looked at that in year 10. So let's have a look at what it will look like. We have our Cartesian plane. We've got y and x. It looks like this. Okay, so you need to know this graph. You need to be familiar with this graph. It is called a hyperbole or a hyperbola. The thing that we need to note on this graph is, see that x on the bottom there? That x cannot be equal to 0 because we can never divide by a 0. So if you were to pop that on your calculator, you would get an error, and we'll look a little bit more at that during the year this year. But what I talked to you about in our last topic was when we have something like that happening where we can't divide by 0, graphically, that's an asymptote. So x equals 0 is going to be an asymptote. Now, if I was to play around with that graph and have y equals 1 over x, and I multiplied both sides by x and divided by y, I could have it as x equals 1 over y as well, in which case y also could not be equal to 0. So that's another asymptote. So if you have a look over here, our y-axis, which is x equals 0, and our x-axis, which is y equals 0, are both asymptotes on that graph. And that's going to help us out with our domain and our range. But first of all, is it an odd or even function? We're going to test for even, and we can test if f of x equals f of minus x. Let's have a look at that. Okay, so if we were to test if f of x equaled f of minus x, so f of x is 1 over x, f of minus x is going to give us 1 over minus x, which is not equal. So it's definitely not going to be an even function. Let's test it for an odd function. So I might write that one up there. So an odd function test says that f of minus x will be equal to minus f of x. So we saw f of minus x a minute ago. That was 1 over minus x, which is the same as minus 1 over x. And minus f of x would be equal to minus 1 over x, which is the same. So that would be an odd function. Now, the definition of an odd function is it is reflective through 180 degrees. So if I was to reflect this side of my hyperbola over to here, and then reflect it back down again over the x-axis, that's what the 180 degrees means. So in this case, yes, that reflects through reflects through 180 degrees. So our function is an odd function. So I've circled odd over here. Let's have a look at our domain and our range. Our domain are our x values, our range are our y values. So in our x values, we've already said that we can't have x equal to 0, but all our other x values are going to be fine. We can go up to infinity and down to minus infinity. So we can just say all x values or all real x values except x equal to 0, and the same would be the range. We can have all values of y in there, we just can't have it touching the y-axis because that's an asymptote. It gets really, really, really close, our graph, on both sides and up here and here, but we cannot have it equal to 0. So the same as our x, we say all y values except y equals 0. Okay, let's have a look at our next one. Now, I don't expect you to be able to do number 3 yourself, plotting it yet. Okay, so I'm happy to use GeoGebra. So we might have a little look at that graph on GeoGebra. But straight up, let's see what it says. It says f of x equals x over x plus 1. Now, without doing anything, I can actually see what my asymptote is going to be. Well, one of my asymptotes is going to be. It's easy to find one of them. The bottom line, we can't divide by 0. So x plus 1 can't equal 0. So if I rearrange that, x cannot equal minus 1. So we're going to have an asymptote at minus 1. Finding the other asymptote is a little bit harder at this point. We need to do a little bit of rearranging, but we will be able to do that towards the end of the topic, and we're going to find that the other asymptote is equal to, but y equals 1 is another asymptote. Now, we'll jump over to GeoGebra, have a look at that graph, and we'll see in a minute what it looks like. But let's see if it's an odd or an even function first. Okay, so I've jumped over to GeoGebra here, and what you can see is that the first asymptote I said that we would have would be x cannot equal to minus 1. So there is a vertical asymptote here of x equals minus 1, and I said we'd soon be able to figure out the next asymptote, but for now I'm going to give it to you. Y is equal to 1. So there are our two asymptotes. Okay, so if you have a look at this graph, it is obviously a form of a hyperbola, and it does not look like it's symmetrical around the y-axis or the x-axis, and it's not rotated nice and neatly. So just by looking at it, I'm assuming that it's not going to be odd or even. But let's go back and see what we can do. Okay, so we know it's not going to be even just by looking at it, but let's mathematically prove that to ourselves. Let's see if f of x is equal to f of minus x. Now, f of x is equal to x over x plus 1. F of minus x, we're going to replace all our x's with a minus x, and we have minus x over minus x plus 1. It doesn't look like they're equal, but let's see what we can do. Can we pull that minus out on the bottom line and get rid of the minus and see what happens? So if I pull that minus out on the bottom line, I'm going to get x minus 1. I can cancel out those two minus signs, and I end up with x over x plus x minus 1. So these are not the same. So it's definitely not an even function. Let's test for odd. F of minus x equals minus f of x. I'm assuming it's not going to be odd just based on what it looks like, but we'll see anyway. So f of minus x, we worked out to be this one here. That was x over x minus 1. Does that equal minus f of x? Well, let's see. That would be minus x over x plus 1. They're not the same. So it's not odd and it's not even. So it's neither. Now let's have a look at the domain and our range. If we jump back into GeoGebra to see what that looks like, there the graph is again. So we're going to have all x values except for x equal to minus 1 because that was an asymptote. And we're going to have all y values except y is equal to 1 because that was our other asymptote. Jump back in and we'll pop that in. So domain, all x except x equals -1, and our range is all y except y equals 1. Okay, so we're just going to have a little review of linear graphs here. A linear function is a function whose graph is a straight line. So these are the easy ones. There's no curves, there's no parabolas, they're just nice and easy straight lines. And there's two forms that they take, which you have seen before. There's this first one, y equals mx plus c, or you might see it as y equals mx plus b, or some other letter at the end, where the gradient is m and that constant term at the end, whether it be b or c, is your y-intercept. And that's how we've been looking at sketching graphs in the junior school, finding gradients and finding the y-intercept. But we can also have this as our general form of a straight line. ax plus by plus c equals 0. So everything is popped over onto the left-hand side of the equation and it equals 0. It's just like rearranging the gradient form up here, getting everything to the left so we have it equal to 0. Now the intercepts. Now we've looked at those very recently, last lesson and the lesson before, but one of the most useful techniques is to find the x and y intercepts. The x-intercept happens at y equals 0 and the y-intercept happens at x equals 0. And that is what we're going to use for curve sketching. So remember, in this topic, we're not looking at plotting diagrams and plotting graphs. We're looking at sketching them. It's a nice quick way, and that's how we're going to do it, and that's what we're going to use. Okay, let's have a look at our example. Sketch the function f of x is equal to 2x minus 3 and state the domain and range. So we don't need a table of values. We're going to have a look at where it cuts the x-axis, where it cuts the y-axis, and that's all we need to know. So our graph cuts the x-axis at y equals 0. So let's work that out. Okay, y equals 0 is just f of x equals 0. So I'm going to have 2x minus by 3 equals 0. Let's solve it. Add 3 to both sides. So 2x is equal to 3. Divide by 2. X is equal to 3 over 2, or 1.5. So it's going to cut the x-axis at 1.5. Let's see where it cuts the y-axis. Remembering it cuts the y-axis at x equals 0. You can straight away think of what our formula that we used for the straight line was up here. Y equals mx plus b, and that number by itself at the end is the y-intercept. So you might straight away go, oh, it's minus 3. But if you don't remember that, we are going to write it as y is equal to 2 times 0 minus 3 gives us minus 3. So it cuts the y-axis at minus 3. Let's sketch it. Remember, in sketching it, we're not looking at plotting it. We're just getting an approximate idea of what's happening in here. Just quickly draw an x and y axis. It's going to cut my x-axis at 1.5. So I'll put 1 and 2 in there. It's going to cut in here. It's going to cut my y-axis at y is equal to minus 3. I'll just pop it in there so it's a little bit more to scale. It's going to go through those 2 points here. We're just going to be checking one other thing and just making sure we're going in the right direction. Our gradient, m is 2, it's positive, and a positive line slopes in the direction that we've got it. So that's good. Okay, domain and range. Domain are our x values. What are our x values? Well, that's going to be all values of x. Our line doesn't have a restricted domain there. So we'll say all real x values. And our range is going to be the same. There's no restriction on that. So we're going to say all real y values. Okay, so I've moved down to the next example. The first one here says a sketch y is equal to 1. State the domain and range. So y equals 1 is going to be this point here. It's going to be parallel to the x-axis. It's going to be this line. So no matter what happens to x, y is always going to be equal to 1. So our domain and our range. Well, our domain is going to be all x values. It just happens that y is going to be equal to 1 for each one of those. We'll say all real x values. But our range, what happens to our range? Well, y is only equal to 1. That's all that's going to happen. Y can't equal anything else. So that's a nice and easy one. Similar to the next one. Sketch x equal minus 2 and state the domain and range. So x equals minus 2 is down here. So it's going to be parallel to our y-axis. So it's saying that no matter what happens to y, x is always equal to -2.